Welcome back. Today we're going to talk about the idea of what a confidence interval is. And the idea behind a confidence interval is we are engrossed with data. We have so much data. And there's so many, data points in a population. For example, the heights of 16-year-old females or the height of a 25-year-old male, whatever it happens to be. Think of these huge populations. And so there's definitely a mean or a proportion that we're dealing with for the whole population, but we get samples and we look at samples, and we spent chapter 7 looking at sampling and what the distributions of samples look like, and in theory, what was it, and is it possible? Like, do our actual data points match up with the theory? And so what we're doing today is we're talking about confidence intervals and finding a value with an interval around it so that we can say we are pretty confident that the true mean of heights for high school seniors is within this interval, or how close can we get, how confident can we be that a certain interval contains the actual value that we want. So when we talk about a point estimate, it's just that. It is an estimate, and estimates are just that. They're not exact values, but, where's my cursor? Hold on. Plug in here. There we go. Estimates kind of give us an idea of where would the mean be. So we're going to have an estimate of where the mean would be, but it's not necessarily going to match up with the true mean. And so we want to try to get as close as possible, obviously. But we're going to be dealing with a point estimate that is a statistic that provides a reasonable guess about the population parameter. Okay, statistic that provides a reasonable guess about the population parameter. So what we're going to use is we're going to talk about, like we did last chapter, p hat is going to be our population statistic, our statistic, and p is going to be our parameter, and then x bar is going to be our statistic, and mean is going to be our parameter. So how do we do it? Well, our confidence interval is we take our point estimate and we have an interval around it, so an equal distance on either side that tells us here's a range of values where we think the true mean might be. So, confidence interval. And we're going to talk about how do we hone in on making it wider to encompass more values or making it narrow to encompass less values. But the point is, a confidence interval is equal to the point estimate plus or minus the margin of error. Okay? So for a confidence interval, A to B. So for example, my confidence interval will be from value A to value B. My point estimate is equal to A plus B divided by 2. And why does this make sense? Well, if you think about it like this, if I have an interval, and let me grab a different color here. If we think about an interval here. And so if we think about what that means, anytime you have an interval, let's not talk about confidence interval, let's talk about just an interval on the coordinate plane, right? So if I have an interval from, let's say, 1 to 5, right? So the range of AP scores, yeah? So 1 to 5. Let's say that was the range of AP scores for a given class. If I want to find the point estimate, like what might be the point estimate if I say the class scores are between 1 and 5, the best guess that we can do from that would be to say 1 plus 5, which is 6, over 2, which is 3. So 3 would be right in the middle. It's really just an average. So if I know an interval, the very middle is the best guess I can put on that. Okay, and that's going to be our point estimate. Our margin of error is the variance between the two values divided by 2. Right, so the total, and another way to think of it might be the total distance covered. Grab my pen here. B minus A, not 5, A over 2, which in this case, our variance would be 5 minus 1 over 2, which would be 4 over 2, which would be 2. So really, I mean, think about it like this. I take my point estimate, so go up here. So here's our example, right? So I'm going to put this up here. So if my point estimate is 3, based on being in the middle of that confidence interval, and I do plus or minus 2, which was the total distance divided by 2, that gives me 2 on either side. So I've got from down to 1 up to 5. And that's how a confidence interval works. I don't think it's anything new necessarily, but we're calling it something new, right? Instead of calling it, average, or calling it, distance on either side, we're calling it a confidence interval. So don't overcomplicate it in your mind. A confidence interval is just an interval that we're saying we're confident the mean is in here, and it's the distance on either side is the margin of error. So how do we interpret this? So here's our interpretation. Can you see that? Probably not. Let me get a little bit darker color. Boom, right there. Too dark. Interpretation. So how do we interpret this? We are blank % confident that the interval from A, and this is the blank, right, to B, we are 90% confident that the interval from 1 to 5 captures the true blank, so parameter could be parameter, captures the true mean, captures the true proportion of, and then insert the context. An example of this might be, we are 95% confident that the interval from 1 to 5 captures the true mean of AP scores for a given class. So you fill in those blanks to interpret the confidence interval, okay? And it's important to note, and I'm going to put this in red because it's very important to note, a confidence interval captures plausible values. This is kind of that theory, right? So these may not even have shown up, but this is what's plausible, okay? So let's go down and look at a check your understanding and look at a specific problem. The Pew Research Center and Smithsonian Magazine recently quizzed a random sample of 1,006 U.S. adults on their knowledge of science. One of the questions asked, which gas makes up most of the Earth's atmosphere? Hydrogen, nitrogen, carbon dioxide, or oxygen? A 95% confidence interval for the proportion who would correctly answer nitrogen is 0.175 to 0.225. So half the battle really is figuring out what this is actually saying. So they asked a bunch of people, 1,000 people, 1,006, which gas is the most common. And the confidence interval says we're confident that from 17.5% of people to 22.5% of people actually got this right. Okay, so that's kind of what we're saying. Like we set this interval, so between 17.5% and 22.5% of people got it right. So what we're saying is because it's a 95% confidence interval, we are 95% confident that the interval from 0.175 to 0.225 captures, this is where you fill in the blank, the true proportion of people who would correctly answer. Okay, 95% confident that that interval captures the true proportion of people. So the point estimate, so where are we at? So our point estimate is 0.175 plus 0.225 over 2, which is equal to 0.20. So if you can imagine this visual, right? So here's 0.175. Here's 0.225. And here's 0.2. This is our point estimate. It's directly in the middle. This is our margin of error. And the way to calculate it would be margin of error. And as you can see from this visual, right, there's a couple ways to calculate it. But in general, it would be our larger minus our smaller divided by 2, because the total distance between them divided by 2, because there's the margin of error on either side, is equal to 0.025. Okay, so that's, obviously you can see, here's our point estimate here. Our margin of error is on either side to complete that interval. If people guess one of the 4 choices at random, about 25% should get the answer correct. Does this interval provide convincing evidence that less than 25% of U.S. adults would answer the question correctly? Explain your reasoning. So all of the plausible values in that 95% confidence interval are less than 25%. Okay, so it does give convincing evidence that less than 25% of U.S. adults would answer correctly. So what we're saying is, if people just guess, they get 25% correct, but our whole interval is below that. Okay, so it does give convincing evidence. There is that the true proportion is less than. So why is that? We'll think about it like this. We're 95% confident that our answer is between 0.175 and 0.225, which means that we are like 5% confident that it's outside of that, for example. So 0.25 is way over here, right? So I say way over here. Here's 0.25. There's a 5%, we're 5% confident that it's outside, not at 0.25, that it's outside of this interval. So anything else besides what's in 0.175 or 0.25, right? So because our 95% confidence interval again, our whole confidence interval, 95% confident that the actual answer is in here, is below that. So there's a 5%, we're 5% confident that it's outside, not at 0.25, but 5% confident that it's outside at any other value. So that gives us convincing evidence that perhaps it's less than the 0.25, all right? That's the basics of confidence intervals and point estimate and margin of error. Thanks for watching, and we'll see you next time.